Okay, so we're on to 11.6, fluid needs for active individuals. And so maintaining water balance is critical for physically active people. The body depends on water for evaporative cooling, and so when you sweat, evaporative cooling happens. When that water leaves your body, sweat leaves your body, it takes with it energy, heat, and so your body's able to cool. That's how we maintain body temperature when we're exercising. Inadequate fluid take before, during, or after exercise can lead to dehydration and heat illnesses. Okay. 2% of weight loss through sweating will put athletes at a risk for dehydration, which leads to, a decrease in endurance, strength, and overall performance. You need fluids to maintain blood volume, again, regulate internal temperatures through sweating, and prevent things like heat exhaustion, heat cramps, and heat stroke. And we're going to talk about those three. So heat exhaustion is going to be the first stage of heat-related illness. Symptoms: profuse sweating, headache, dizziness, nausea, vomiting, muscle weakness, visual disturbances, flushing of the skin. Individuals who are showing these symptoms should be taken into a cool environment, and any excess clothing should be removed to try to bring down body temperature. Next would be heat cramps. These are a complication of heat exhaustion. This happens in your skeletal muscles, so again, the muscle attached to your bones. The cramps are the result of contractions lasting 1 to 3 minutes. They move down the muscle and they cause excruciating pains. To prevent heat cramps, you should start with moderate exercise, have adequate salt intake, so you have to have the right electrolyte balance, and avoid becoming dehydrated. And we'll talk about symptoms of dehydration in just a second, but it's not just, you don't want to wait till you're thirsty. You want to make sure you're getting adequate fluids and adequate electrolytes before dehydration. Okay, and then lastly, here we have heat stroke. And so this is when internal body temperature reaches 104 degrees Fahrenheit, which is a high temperature. Sweating stops. Symptoms include nausea, confusion, irritability, poor coordination, seizure, hot but dry skin, rapid heart rate, vomiting, diarrhea, could lead to coma, and death could occur if untreated. How do you treat this? Cool the skin with ice packs or cool water to bring down that temperature. Okay. Just to show you heat index, so how hot it is outside is a factor of both air temperature as well as relative humidity. So if it's 75, let's say 85 degrees outside, but it's 90% humidity, it's going to feel like 102. So we got to kind of keep that in mind. And outdoor activities, running the Boilermaker, when it's 90 out and it's 90% humidity is not a good thing. That again will feel like 122 degrees Fahrenheit. Okay, so between 80 and 90 degrees, fatigue, 90 to 104, sunstroke, heat cramps, heat exhaustion can occur. Higher than that, heat stroke is possible. And then 130 degrees or higher, heat stroke, sunstroke are likely. Okay, being in direct sunlight increases the heat index up to 15 degrees Fahrenheit too. So, okay, so dangerous. Okay. Fluid intake and replacement strategies. Here on the right is the color of urine test. Okay, so optimally hydrated individuals, urine should be of this shade. Slightly dehydrated, meaning you should drink more, here. And then very dehydrated must drink more down here. You never want to be down here. Okay. It is suggested, it's recommended that individuals do not lose more than 2% of their body weight, during exercise. And it's recommended that individuals weigh in before and after exercise. I have a good friend who does Ironman, and it's a triathlon, and I don't remember the mileage, but they are, running biking and swimming, not in that order. It takes him all day to complete it. He's a very fit guy, but he loses like 8 or 10 pounds in that one day of racing. It's very dangerous. So again, it's, you should weigh in before and after exercise. You shouldn't lose more than 2% of body weight. For every pound loss, you should drink 3 cups of fluid. And be careful here, electrolytes are important too here. And so, you don't want to just drink plain water. We'll talk about that a little bit more in a minute. If you can't monitor weight changes, then you should be assessing your urine color. And again, you can use this chart here. And your urine should be no darker than lemonade, although lemonade comes in different shades, so this might be a little bit better. Thirst, again, is the last sign of dehydration, so you shouldn't wait until you're thirsty. It's not a reliable indicator of the need to drink fluids. Okay, before you exercise, you should drink freely. 24 hours before the event, just like you would normally drink in a normal day. 2 to 3 hours before the event, you should drink 2 to 3 cups. And then 10 to 15 minutes prior to the event, you should drink another 1 to 1.5 cup. During exercise, you should drink every 10 to 15 minutes. It depends on the exercise, but on average, 1 to 1.5 cups. Drink enough to maintain weight. So whatever you're losing in sweat, you want to replace that. If you are exercising for more than an hour, your beverages should not just be water. They should contain 4 to 8% carbohydrates and 0.5 to 0.7 grams of sodium per liter. So this is really important. If you're just doing a 30-minute, jog, 30-minute swim, 30-minute, exercise tape, lifting weights for 30 minutes, you're fine with just water. But if you go over an hour and you're doing moderate intensity activity, you want to make sure that you're not just drinking straight water. You want to have carbohydrates and sodium, electrolytes. After exercise, drink 3 cups again for every pound loss. Restore weight before the next exercise period. This is for an individual not looking to lose weight. This is for an athlete that's trying to just maintain weight. Can you drink too much water? Yeah, this is called water intoxication, most often caused by over drinking without replacing sodium loss. So just drinking straight water without electrolytes is not a good thing. You can prevent this, again, by drinking beverages that do contain sodium, consume enough fluid during exercise to minimize weight loss during exercise, and then consuming sports drinks with 100 milligrams of sodium per 8-ounce serving is a good idea. Okay, talk a little bit more about sports drinks. There's a lot of different drinks on the market. You should definitely look at the nutrition facts panel. Again, sports drinks are more important for activities that last longer than 60 minutes. Activities that last less than that, straight water is usually fine. If you're over 60 minutes, you need to replace glucose lost by muscles as glucose is used. That's going to enhance performance. And again, electrolytes. And so you want to make sure you're maintaining blood volume, and you want to make sure you have enhanced absorption of water and carbohydrates. You need electrolytes to do that. You should avoid beverages that have alcohol in them, caffeine, carbonation, and sugar content above 10%. So again, you got to be careful with sports drinks. You want to make sure that those types of things aren't in there. Alcohol I wouldn't worry about, but caffeine, carbonation, and sugar content are all things that I would really, watch for. Okay, and we'll do part 7 here as well. So this is food and fluid intake before, during, and after exercise, and we did some of this fluid stuff just now in 11.6. Composition of food and fluids before, during, and after exercise can affect how the individual performs, and also the speed at which the individual is able to recover. Careful planning is definitely needed to make sure that all of the athletes' needs are being met. Okay, so before you exercise, We talked about fluid intake in the previous set of, in 11.6. Okay, so you should look back there. The pre-exercise meal is going to keep the athlete from feeling hungry before and during the event, and it's going to help the athlete to maintain optimal glucose levels while exercising and improves performance. Pre-exercise meal should be high in carbohydrates. You want to make sure you have glycogen stores. So 4 grams per kilogram of body weight, about 3 to 4 hours before the event, and then 1 gram per kilogram of body weight 1 hour before the event. So you want to make sure you have appropriate carbohydrates. Fats, you want to have a lower fat meal. Less than 26% of the calories should come from fat when you get close to the event. You should avoid any foods that promote gas, right? And you should make sure that whatever you're eating is highly digestible. So you want to stay away from, fiber, which is not highly digestible, okay, before doing some type of an athletic event. During, for events that last longer than an hour, you want to try to consume 30 to 60 grams of carbohydrate per hour. You can get this with sports drinks if they have 6 to 8% carbohydrates. You can do this with the little carbohydrate gels. My kids, when they run long races, there's these little jelly beans. They're not actually jelly beans, but they look like jelly beans that they put in their mouth and chew on and suck on, while they're running. Again, they're high in carbohydrates. Okay, so you're getting your blood glucose levels back up. You could also chew on an energy bar. My kids like these things called Stingers. You want to look at the label, make sure that they have 40 grams of carbohydrate, but again, they're not too high in protein, fat, or fiber. Okay. And then recovery. So how about after? After an event, you should eat food that promotes protein synthesis and, more importantly, maybe reloading glycogen stores. So you want to eat high carbohydrate and low amount of protein type of a meal. So you want to consume about 1 to 1.5 grams of carbohydrate per kilogram of body weight within 30 minutes of finishing an exercise. And at 2-hour intervals after. Immediately after exercise, cells are more sensitive to insulin. High glycemic foods work best. They're going to bring you back to levels that you need. And then again, eat small amounts of protein with that carbohydrate. And then fluid is definitely important, and electrolyte, fluids with electrolytes. Okay, last part of the chapter, we'll do this quick. This is 11.8, ergogenic acids and athletic performance. So what are these? So ergogenic acids are substances that are used to improve exercise and athletic performance. Okay, there are lots of stuff on the market. It is not regulated by the FDA, or it's limitedly regulated by the FDA. And so, it's tough. Many of these products are not effective. They make claims that that don't actually hold true. And some are actually dangerous. Reliable research and accurate information on these products is hard to find. And again, the FDA really has limited ability to regulate these because they're considered to be dietary supplements. Manufacturing of these is not tightly regulated. So, not great. The National Collegiate Athletic Association's Committee on Competitive Safeguards and Medical Aspects of Sports has made these lists, permissible and non-permissible lists, for what athletic departments at colleges can distribute to athletes, dispense to athletes. So permissible, vitamins and minerals, energy bars, if they are not, I forgot the number there. We'll just say high percentage of protein. Carbohydrate and electrolyte drinks can be distributed. And then caffeine, I forgot the number there too, not to exceed a certain amount of micrograms per milliliter. Non-permissible, so things that they cannot distribute or dispense to students, amino acid supplements, creatine, which is something that a lot of individuals take, glycerol, beta-hydroxy, beta-methylbutyric acid, which is HMB, any kind of a stimulant, or protein powders cannot be distributed. Okay. And the last couple of slides here are just shows us different supplements, what they might be used for, and reality, or what they claim that they might be used for, and then reality. So creatine, people take creatine to increase phosphocreatine in muscles, which keeps ATP concentration high. So use 20 grams per day for 5 to 6 days, and then maintain a dose of 2 grams per day. May improve performance in athletes who undertake repeated bursts of activity, such as sprinting and weightlifting. Vegetarian athletes might benefit because there's very little to no creatine in their diet. There is some muscle weight gained, but the results are usually from water being contained in that muscle. Endurance athletes have not been shown to benefit from it. Little is known about safety of long-term use. Continual use can lead to kidney damage. Okay, cost, it's expensive, 25 to 65 bucks a month. Beetroot juice. This is a source of dietary nitrate. Positive effect of high intensity exercise in lab experiments. Exercise tolerance is improved. So again, some evidence to suggest this might be useful. Caffeine, it's a stimulant. It's cheap. There are possible side effects like increased blood pressure, increased heart rate, intestinal distress. But again, it has been shown to improve performance events. Okay. And I won't go through all of these, but here's just a couple of more examples. And then at the bottom here, I like this because it's dangerous or illegal substances. Okay, so steroids, anabolic steroids, growth hormone, blood dropping, GHB, gamma hydroxybutyric acid. Okay, so again, I won't read all this to you, but there is evidence for some of these things to be beneficial. Some of these things have pretty dangerous side effects. So again, before you use any of these, you should do your research. And that concludes Chapter 11.